Okay, so we did 473 plus 289. So my challenge to you is to see what you can come up with in terms of exploding pebbles in these magical machines for 473 minus 289. Okay? So just work on that and tell me what you come up with and see. Oh, question? Oh, you're still on the 10-1 machine. Yeah, 10-1 machine. I mean, if you want to do all this in the 2-1 machine, you can, but just the fact that we call the number 473 is just a reminder that we almost always use base 10 machines, right? 10-1 machines for everything. Yeah.
Trading. I'll be back.
But if
why wouldn't you start at ones?
But the exploding goes
That's true.
forward, right?
Yeah, you're right.
So you want to
Does
know
it
what?
happen?
Can you unexplode things? No.
Unexplode, yeah.
Can you move this rock knowing that it's going to create 10 rocks over there?
Well, in fact, you can. You said 289. You start with the 9. Take away 9. Well, we can't take away 9 here, so we bring one of these rocks, bring 10 over into here, take away the 9.
We have
The
to.
big one explodes.
It's like borrow. It's your borrow.
Yeah, but I think he wants to use exploding and unexploding. Right. So,
But then once you have your 9, then you. Okay, I got you.
so if you want to use the language of exploding,
You got to invent your own story involving these magical machines for this subtraction problem. Tell me what you come up with.
So explode a rock back into
all right. What explodes?
Right. I mean, so the tricky part here, of course, is not getting the answer because you all know how to subtract. But how do you explain the answer in terms of machines and pebbles and explosions and stuff?
Yeah.
Three different types of
explosions.
Yeah.
10.
Oh, you want to start at the 9?
1.
It's 80, right? Yeah. You take away 1 from that. And you add those 10 back to that.
Yeah.
So you had 83 and then I'm taking 1, right?
You're taking 1 out of here.
You can probably.
Just 1?
Take 1 of these and add your 10 back here. Because it's pre-explosion, right?
If you can't take it down,
Then you got to cross 1 off. You do that. Or you already did.
or 8.
Because you took away 8.
Yeah.
But then you have to cross out.
So we're not allowed to run the machine.
I haven't. You have to figure out something that makes sense in the machine story. That's the only rule here. So anything that you want to make up that you can describe in terms of machine is fine. Yeah.
How do you make it? Yeah.
Run the machine backwards. The machine explodes. Then you
That's right.
he's 80 of these. I mean, he's
Seven.
You usually go in one direction, right? But this really is.
so now he's going to 7 over here.
So now you have
But
to.
that says we have to take away 8. So we have to unexplode one of these rocks. We got to put 10 over here.
So like start.
Now we can take away 8 of those.
That leaves.
Now that leaves 3 over here, and we've got to take away 2, but we can easily take away 2. Right?
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 23. No, it's not 183.
Yeah, so, but I mean, in a
Right,
certain
4.
sense, the only thing is we know the answer in each one. That's the thing. So it's not like the other one had just like a single operation, dropping rocks,
Right.
pebbles
That's what I'm
into one
saying.
box,
It's
and then they
like
explode.
very confusing.
And you're having a different
so-
sort of thing in each.
And then I think maybe something will happen, and then it's going
And
to
then see they have a
become
problem. So they can
one.
do, yeah.
So take 2 from there.
And then you get here and you're like,
Oh no, this is a 4, so it's 2
and you
2s.
take
So
away.
this is going to be.
Well, let me take one of these and unexplode it. So that's how you.
No 0. Okay. And then 8 0 0 0
So then I have
0
But see how I realized now I have 100 more.
And I had a,
Oh, you didn't subtract this the first time. It shouldn't be 384.
so it should be 184. First thing has to be a 2 because otherwise you actually get
took one of
the
them,
denominator.
and now you put 10 back.
Good. Yeah, do an easier problem, of course.
Unique representation.
And so, what was your machine technique to make it go?
Well, 10 of these make 10 of those, so pick one of those.
Yeah. Yeah.
One of those, and I move 10 over. I remove one.
So you basically anti-exploded or something.
Right,
Uh-huh.
right.
Unexploded. Unexploded. Yeah, sure.
Move 9, then remove 1.
Great.
And I use just a numeric way. It's pretty much like borrowing.
But it's the same thing. You just unexploded one of these pebbles to make 10 of those.
And
Yeah.
then I unexploded
This is a
one
pebble way.
back, and
Yeah.
then I do the subtraction.
Yeah. That's great. So can anybody summarize your algorithm here?
Well, it's basically the same thing. Like, I don't know if you wanted a picture or like.
However, just I want the words eventually too, but yeah.
The way I first started out was doing just like you did the addition. I did 4 minus 2 and got 2. 7 minus 8 got negative 1. 3 minus 9 got negative 6. This is great for middle school people that hate negatives. This gives them really good practice. So then you can't leave an answer. So you can't have 2 negative by negative 6. So to make it a I have to borrow.
Right. So what does the borrowing mean in terms of the machine?
So if you take 1 dot away here, it leaves you with, it gives you 10 dots there. And then you can't have the negative 6 and 1, so you've got to take 10 dots, move it to the other. Or 1 from that dot to bring it back to the 10.
Could you show everybody this on the board?
Sure.
Thank you.